Welcome to Scratch Academy. Today, we will make simple platformer in Scratch. It was simple and easy for beginners. Let's make it. First step, upload your backdrop. Next, upload the other backdrop. Off course, we have 14 backdrop. You can scroll to look to the other backdrop. Second step, upload your sprite. Ground sprite, lava sprite, spike, and player, our main character. We started with the thumbnail sprite. When green flag clicked block, we immediately use the set ghost effect to 100 block. This makes our sprite completely invisible, but unlike the regular hide block, it still stays active on the screen. Next, the script enters a forever loop. Inside this loop, it constantly triggers the go to front layer block. This ensures that even though the sprite is hidden from view, it permanently stays on top of every other asset in the project. Next, for the ground step, when the green flag clicked, switch the costume to number 1. There are 14 ground, and you can scroll to look at it. To handle moving forward, we use a simple event listener. When the sprite receives the broadcast message, Next Level, it triggers the next costume block, smoothly shifting the game to the next layout or backdrop. When the project receives the broadcast message, Previous Level, it runs our custom Previous Costume block, successfully stepping the player back 1 level. Before that, we built a custom one, under Define Previous Costume. When we define Previous Costume, we use a little math. We tell it to switch costume to whatever the current costume number is, -1. Next, copy code in ground sprite and paste in spike sprite. Do the same thing to lava sprite. For the lava sprite, everything starts when green flag clicked. The very first thing we do is use a go-to back layer block, which sends our sprite all the way to the background so it won't block any other characters on screen. Right after that, we reset its look by telling it to switch costume to 1. Next, we drop into a forever loop to create a continuous. Inside the loop, the sprite takes 1 second to glide up slightly to an X of 0 and a Y of 10. Then, it takes another second to glide right back down to its starting position at X0, Y0. Now copy and paste several code in lava sprite to backdrop. Click to the backdrop. Make a variable timer. When the green flag is clicked, both of these scripts kick off at the same time. They both immediately make the timer variable visible on the screen and reset its value to 0. We enter a forever loop that constantly checks our progress. If the backdrop number becomes greater than 13, meaning the player has cleared the main part of the game, the script hits Stop this script to freeze the timer. Otherwise, as long as we're below backdrop 13, the else branch runs continuously, setting our custom timer variable to match Scratch's built-in, high-precision timer block. The next one. We use same formula on start game. We keep things simple for the audio. Once it passes the initial setup, it enters its own forever loop, playing the track The Green Orbs Bike Rides all the way until it's done. As soon as the song ends, the loop triggers it to start right back up again, providing seamless background music for the project. Click the player sprite. Let's look at how we handle jump inputs for this platformer setup. When the green flag is clicked, the script immediately resets the character's position, placing them at an x of -168 and a y of 0. Then, it jumps straight into a forever loop to constantly listen for player input. Inside the loop, we have a massive conditional statement checking for a jump. It's looking for a few different inputs. If the spacebar is pressed, or the up arrow key is pressed, or an external joystick input, stick Y, is pushed up past 0.5. But there's a catch. All of those button inputs are wrapped in an AND statement with a ground check. The jump will only trigger if the variable in air equals 0, meaning the player is safely on the ground. If they meet one of the inputs and are on the ground, the script sets both in air and gravity to 1, initiating the jump and preventing them from infinitely jumping mid-air. When the green flag is clicked, we want it to start at an x of -168 and a y of 0. Once it's in position, it jumps right into a forever loop. Inside the loop, things get interesting. We have a wait 0 seconds block, followed immediately by create clone of myself. When I start as a clone, the first thing it does is clear graphic effects. This ensures the clone starts fresh and fully visible, resetting any transparency or color changes it might have inherited from the original sprite. Next, we create the fade-out effect using a loop. The script runs a repeat 10 block, and inside, it tells the sprite to change ghost effect by 10. Because it does this 10 times, the total transparency hits 100. Finally, once the animation finishes and the clone is completely invisible, it hits the delete this clone block. When the green flag is clicked, we reset the character's position to an x of -168 and a y of 0. Then, we jump straight into a forever loop to constantly monitor its position. Use if block inside forever block. First, the script checks if the sprite moves too far to the right. If the x position becomes greater than 200, it wraps the player back to the left side by setting x to -200 and centering the y-axis back to 0. Next, it handles falling off the screen. If the sprite's Y position drops below -180, meaning it fell into a pit, the script triggers a full reset. It resets its scale with set size to 100%, uses clear graphic effects to wipe away any visual changes, and teleports the player right back to the starting point at x -168, y 0. Don't forget to plug Next Level Block. We have an if block checking if the character is touching spikes or touching lava. If either of those dangerous conditions is met, it triggers a full player reset. During this reset, the script sets the player's size back to 100% and clears any active graphic effects to restore their original look. Right after that, it snaps them back to the beginning of the level by sending them to an x of -168 and a y of 0. But what if they hit something helpful instead? Right below that, we have a second if statement checking if the player is touching trampoline. If they are, it instantly sets their gravity variable to 18, launching them high into the air with a massive boost. Next, let's look at the initialization. When the green flag is clicked, we ensure our character always stays visible by sending it to the front layer. Next, we reset our movement variables by setting both gravity and acceleration to 0. This gives us a clean slate every time the game starts. Now for the core logic, which sits inside a forever loop so the game constantly checks for player input. Inside the forever block, put several if block. Put key block inside if block. Do the same thing in the other block. If the player presses the left arrow key, or if the controller's stick X value drops below -0.5, we do two things. We change our acceleration by -2 to start moving left, and we point the character in direction -90 so they face the right way. We do the exact same thing for moving right. If the right arrow key is pressed, or if stick X is greater than 0.5, we change our acceleration by 2 and point in direction 90. We need some friction so our character doesn't slide forever. We do this by multiplying our acceleration by 0.8 every frame. This creates a nice, smooth deceleration effect when you let go of the keys. Once that's calculated, we update the character's horizontal position by changing X by acceleration. But what happens if they run into a wall? That's where this next block comes in. If the sprite is touching ground, we need to immediately push them back out. We multiply acceleration by -1 to reverse the movement, change X by that amount, and then set acceleration back to 0 so they stop moving completely. We constantly change our gravity variable by gravity. Finally, we check for floor collisions. If we are touching ground while falling, it means we've landed. We set our in-air status to 0. Undo the last downward movement by changing Y by gravity times -1, and reset our gravity to 0. Next, let's handle vertical movement and gravity. We constantly change our gravity variable by -1 to pull the character downward, and then we change our Y position by that gravity value. Sec the result and resec every single number used. And let's try it. If you enjoyed this tutorial, don't forget to like and subscribe, and scratch on